So we are going to solve this problem now. We are asked to find I. So the question is, what is I? I is available here. Actually, we have how many components? This is component number 1, this is component 2, this is component 3, and this is component 4. And when we observe, there are 3 branches here, and this component 1, component 2 are connected in parallel. Similarly, C3, C4 are in series, but they are in parallel with C1 and C2. Okay, so you understood now. C1 component and C2 component and the combination of C3 and C4, these are all in parallel. So why we are mentioning this? Because this 9 volts is applicable for all these cases, right? Here also you have the 9 volts at this branch, and here also 9 volts, and here it is the total of this 3 plus 6. Okay, so 9 volts. But the current will be different here. Here this 8 amps current is passing through this component and it is flowing upward, right? That means it is flowing from minus polarity to plus polarity. That means it is supplying power. This supplies. And how much power it is supplying? That is 8 amps into 9. That is 72 watts. That is being supplied by this C1 component. Okay. Right. When you go for this second component, this current 2 amps is actually entering into this particular component through this plus. So it's like this, from plus to minus, right? So here it is actually absorbing the power. So how do you calculate this power now? It is 2 amps into this 9 volts. That means 18 watts. This is for the C2 component. Okay. Now you go for the C3. So already we know that this 8 ampere current is being supplied by this voltage source, and 2 amps current is here coming. So the remaining would be definitely 6 amps current, isn't it? So on that way directly we can calculate actually the current. So this 8 amps current is equal to that acts as the supply, right? That is equal to, that is divided into two currents, namely 2 amps current plus this I current. So I is equal to 8 minus 2, 6 amps. So we got the result here. For the first question, find I. This is one answer. The second one is power absorbed by each element in the network. So this absorbs 18 watts, and for this case it is C3, right? C3 is also absorbing power. Why? Because the I current is entering into this plus terminal, right? So it is going like this, plus to minus. So therefore it is absorbing the power. And how much power is being absorbed? That is that current I, that is 6 amps multiplied by this 3 volts. That means it is 18 watts. This is by the C3. Then you go for the C4. C4, into the C4 also the current 6 amps is entering into this plus terminal, right? So it is also moving like this. Current is flowing like this from plus terminal to the minus terminal. How much current is flowing? 6 amps current is flowing. So here also it is absorbing the power. The C4 is absorbing the power. How much power? So that current 6 amps multiplied by the 6 volts. So that is equal to 36 watts. Okay. This is by the C4, right? And we know that sigma P, that is conservation of power, that is equal to 0. So using this, we are going to say that this is power 1, this is power 2, this is power 3, this is power 4 by the respective components. So 72 watts is the supplied power, that is equal to the summation of this 18 watts plus 18 watts plus this 36. 36 plus 36, so 72. So this summation of P, that means 72 minus 72, that is equal to 0. So it's proved, right? So we have calculated the power absorbed by each component also. Okay, thank you. Hope you have understood.